So in today's lesson, we're going to learn how to write really big numbers and really small numbers in a more concise way. That just basically means that we're going to take these numbers that take up a lot of space when we write them, and we're going to use a notation called scientific notation to write those numbers in a way that takes up less space. Because if we kept those numbers as they were, really big numbers like 7.6 billion, or a really small number like 8 millionths, if we kept those numbers the way that they were, then they would have a lot of zeros. In the case of 7.6 billion, they would have a lot of zeros to the right of the digits. And in the case of 8 millionths, they would have a lot of zeros to the left of the digits. So we want to find a way that we can take up less space. And when we use operations on those numbers later, it makes life a little bit easier on us because we're not having to deal with all those extra zeros written in the numbers. So the numbers, the way we're used to seeing them, are called in standard notation. Okay, so we're going to take numbers we're used to seeing in standard notation and put them into scientific notation. So the key to scientific notation is that we have to start with a number that I'll refer to as a base number. Now, there are some important things to know about base numbers, that number that we're going to start with when we write in scientific notation. The number has to be at least a value of 1, but it cannot be a value of 10. So what that means when we start writing scientific notation, I can say 1 times blah, 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 but I can't say 10 times blah, blah, blah. Okay, and that times blah, blah, blah is going to be, and I know that's a real technical term, but that's going to be taking that base number and multiplying it by a power of 10. A power of 10 either raised to a positive power or a power of 10 raised to a negative power. So I can have something like 1 times 10 to the third, and that's perfectly okay because that base number is at least 1, but less than 10. But I can't have something like 12 times 12 to the fifth. I'm sorry, 12 times 10 to the fifth, because that base number 12 is bigger than the number 10. So I guess the best way for you to see this is really just for me to demonstrate it. So let's start with this first number down here. This is a fact. If any of you have read about, or if any of you have talked about population and geography, it's, I think, a fairly estimate number for the world's population is 7.6 billion people. Now that number we want to write the way that we're used to seeing it. So let's see. I know there's a 7 and there's a 6, and we know there's going to be some zeros that follow. So 7600. That's 7,600. All right, well, we need to go further. Let's put 3 more zeros. 7,600,000. Okay, we still have more zeros, but that should be the number that we're looking at in standard notation. Let's see, I have a comma every 3, and that is how we would write in standard notation 7,600,000. 7,600,000, 7.6 billion. Okay, so we want to take that number and we want to convert it to scientific notation. So the first thing we need to do is to turn this number into a number that has a base number that is at least 1 but less than 10. So if you visualize the decimal point, it's down at the end of the number right now. Now think about where that decimal point would have to move to create a number that's at least 1 but less than 10. Now if I think, I can visualize that decimal point is going to move right between the 7 and the 6. So that's going to be our base number. We're going to say 7.6. And now what we're going to do is we're going to have to show, because in scientific notation you have a base number and then you multiply it by a power of 10. We're going to say times 10. And the last thing we need to do is to fill in our power here. So I'm just going to put a box up there just so we know. And we're going to take that, where we mark that decimal point now, we're going to count back how many spaces we'd have to send it back home. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. So if I put a 9 in there, that tells me that our original number, 7.6 billion, written in standard notation, would be converted to scientific notation as 7.6 times 10 to the ninth. I don't know why my cursor makes things disappear, but it does. So that is our final number in scientific notation. So that was taking a really big number. Now what we're going to do is take a really small number and convert it to scientific notation. So if you think about 8 millionths, that is a number that's going to have a whole bunch of zeros, but not to the right, but to the left this time. So here's the number 8. And if I put a decimal point there, that's going to make it 8 tenths, if we are correct. So if you saw 0.8, that would just be 8 tenths, but that's not what we want. So we need to erase that. And we need to start again. So let's see, there's 8 tenths, that would be 8 hundredths, 8 thousandths, 8 ten thousandths, 8 100 thousandths, 8 millionths. So that number we just took, it was just written out for us. That number rewritten in standard notation would look like 0.000008, or some people like to make sure we put the decimal out front, 0.000008. That's 8 millionths. So again, scientific notation says you have to start with a number that is at least 1, but less than 10. Now that decimal point keeps disappearing on me, so I might have to fight with it a little bit. Let's see. Get rid of you. Put a decimal point, maybe make it bigger so it doesn't want to go anywhere. There we go. All right. So what I like to do, you noticed in the last problem, I like to use an arrow to mark where I would visualize that decimal point now that it's moved. So if I think about moving that decimal point to make a value of at least 1 but less than 10, I can visualize that decimal point going now to the right of 8. So that would give me 8. Now, that's the first part, or a base number of our number in scientific notation. So now I'm going to have to say times 10. And I'm just going to have to figure out what power I raise that 10 to. So if I think about where I've moved my decimal point to, how am I going to send it back home? I'm going to send it to the left. I'm going to go, whoops, let's see if I can do this again. I'm going to go 1, 2, 3, 4, 5. I'm going to go 6 spaces back home, which tells me that is going to be times 10. But because I'm moving to the left and making the number smaller, it's going to be times 10 to the negative 6th. So 8 millionths in standard notation, 0.000008, written in scientific notation, would be 8 times 10 to the negative 6th. So I'm going to leave 2 more examples for you to work on your own. One, a really large number, the estimated cost of damage for Hurricane Sandy. And notice that number is already in standard notation, so you just need to follow the steps that you saw above to convert to scientific notation. And then the other is a really small number, the radius of hydrogen, which I'm not even going to begin to read that number off. But we can see with all those extra decimal points, it's a really small fraction of a number. All right, so I want you to check in, I want you to do those, and we will check on those in class. Okay, so the second part of our lesson, we're going to turn the notes over, and it's going to have us work in the opposite direction. So when we are already in scientific notation, as you can see we are, because we have 3.18, that's a number that's at least 1 but less than 10, times 10 to a power. then that's already taken the number and written it in scientific notation. So if I want to work in reverse direction and put that number back in standard notation with all its extra zeros, then the first thing I'm going to do is write the base number, the 3.18. And I'm not going to worry about the power of 10 there. But what I am going to notice is that because my 10 is raised to the 7th power, that's going to tell me that I need to move to the right. Move to the right with my decimal point, specifically 7 spaces. So I'm going to take this decimal point and I'm going to move it 7 spaces because of the exponent. 1, 2, 3, 4, 5, 6, 7. And I'm going to fill all that extra space with zeros. So that's what my number would look like if I took this decimal point and moved it to where it originally was in standard notation, 7 spaces. So if we finish that up, we would get 318, and it looks like 1, 2, 3, 4, 5 zeros. 4, 5, and now I'm going to just make that number look correct with commas by putting commas in every 3 digits. So let's see, I have thousands, I have 100,000s, I'm into millions. So this number, if we read it correctly in standard notation, originally it was 3.18 times 10 to the 7th in scientific notation. That would represent the value 31,800,000. So that's how we take a number in standard notation, in scientific notation, and we rewrite it in standard notation. So if you take that concept and you work in reverse, or for negative exponents, it's going to be the same idea, looking at where our decimal point is, but this time, because it's a negative exponent, it's going to tell us to move some number of spaces to the left. So move to the left, in this case 4 spaces, because it is a negative 4. So this is going to become a smaller number, whereas up above with the positive exponent became a really big number. So I have 9.075. So I can write that. I'm going to change up my color. 9.075. 9.07. Let's try that again. 9.075, not 9.75. That would throw everything off. 9.075. And now my decimal, that's my base number. And now my my exponent says move 4 spaces, but because it's negative, it's going to be moved 4 spaces to the left. We're going to go 1, 2, 3, 4. So that's where my decimal point needs to go. And I have all of this extra space to fill in with zeros. 1, 2, 3. So if we look at that value, by the time we're done, we have 0 point. Now remember, we like to see the 0 to the left. 0, 0, 0, 9, 0, 7, 5. All right, so let's see. That would be tenths, hundredths, thousandths, 10,000ths, 100,000ths, millions. Looks like 10 millions, 9,075, 10 millionths in this case. Okay, so that is how we are going to convert from from scientific notation to standard notation. We're going to work with our base number, rewrite it, as you can see here, the 9.075 I rewrote, and then I'm going to let the exponent tell me in which direction and how many spaces to move the decimal point and fill the extra spaces with 0. So a negative exponent, remember, we will move to the left, and a positive exponent, we will move to the right. And we'll fill in the extra spaces with zeros, and then we'll put our commas in where we need to, particularly when it's a really big number. All right, so You have a little more practice to do also on this page, so I'm going to have you to take these two numbers here, again, scientific notation, follow the directions, look back at the video as you need to, and convert each of these to standard notation. And once again, we'll complete or we'll review these answers when we come back to class.